Scientific notation. One challenge that is faced by scientists multiple times is that the numbers that they're working with sometimes are either really large or they're really small. For example, the number that you see here, it's the distance from Earth to Sun. This is a really big number, whereas this number right here is a really small number. So these numbers are a little difficult to remember, a little difficult to express. So to make our life easier, so to resolve this issue, people have come up with scientific notation. What is scientific notation? It consists of basically three parts. It has a number which is called as coefficient, which is this part is called as coefficient. A multiplier, which in this case is 10. In scientific notation, that multiplier is always going to be 10. And then an exponent, which is this number that you see in power of 10. Okay, so coefficient, how do we find the coefficient? The coefficient is always going to be a number where the decimal point is located right after the first non-zero digit. Okay, so if my number is 2, 1, 3, 4 or something with a decimal of 2, 3, then for scientific notation, I always want to change this number so that my decimal point lies right after 2. If it is, let's say, 0, 0, 0, 3, 0, 4, 1. Okay, if I want to write it in scientific notation, I want my decimal to be after the first non-zero digit. Your first digit should also always be a non-zero. It cannot be a 0, and the decimal lies always after that. So that is called the coefficient. It is always multiplied by 10, which is your multiplier, and that 10 is always raised to a power. It can be a positive exponent or a negative exponent. For example, this is 10 raised to power -3, which means it's a negative exponent. Or it can also be, let's say, for example, this, it can be 2.13423 times 10 raised to power 4. Okay, or 10 raised to power, sorry, this would be 10 raised to power 3. Okay, so that means it is a positive exponent. So this can be positive or a negative exponent. Okay. Before that, let's look and understand what is exponential notation. Exponential basically means anything raised to the power of a number. In this case, we are majorly focusing on 10. So 10 raised to power 0 is 1. Anything, let's say x raised to power of 0, anything raised to the power of 0 is always 1, which means 10 raised to power 0 is equal to 1. If instead I do 10 raised to power plus 1 on the top here, anything raised to the power of 1 essentially means that same number. So 10 raised to power 1 means it is equal to 10. 10 raised to power 2 means I have 10 multiplied by 10 2 times, which basically will give you 100. So that's this. 10 raised to power 3 means it's 10 multiplied by itself 3 times, which is also equal to 1000. So if you can write the number 10 raised to power 3 or you can write the number as 1000, that essentially means it's the same thing. If I say 10 raised to power 5, that means I have 10 multiplied by 10 5 times, which is also 1, 2, 3, 4, 5. So either you write 10 raised to power 5 or you write this. It's basically the same thing. Only difference is here, this is the exponential notation and this is the standard notation. This is when the power is positive. If your power is negative, that essentially means you have that number, you have 1 over that number. If I have 10 raised to power -1, that means it's 1 over 10 one time, which would give you 1 over 10, which is 0.1. If it's 10 raised to power -2, that means I have 1 over 10, but 2 times. So that is 1 over 10 times 10, which is 0.01. Similarly, 10 raised to power -3 means I have 1 over 10 3 times, which will give you this number. One thing that you might have noticed here is anything raised to power something positive, if it's a positive exponent, for example, in these 3 cases, that just means it's a large number. It's a big number. if your exponent is something negative, that means it's a small number. Like you can see here, as the exponent becomes negative, it becomes 0.1, 0.01, 0.001. So just remember this: positive exponent means large, negative exponent means a small number. Now let's see how you can write the number in scientific notation. It's very easy steps. The first step is locate the decimal point. For example, let's start with this number. I locate the decimal point is located right here. Now, in scientific notation, the decimal point is right after the first non-zero digit. So I need to move the decimal after the first non-zero digit. Okay, so I need my decimal right here. So now let's move it. 1, 2, 3, 4, 5, 6, 7. So I need to move my decimal by 7 place values, and then I would get my decimal at the right spot, which means my new notation becomes 1.42 because I moved the decimal here, multiplied by 10, and this was moved by 7 places, so 7 becomes my exponent. Let's confirm. 1, 2, 3, 4, 5, 6, 7. Correct. 7. Important thing here is you can see this number, beginning of this number, it's a very small number. It was 0.000, which means my exponent should be negative. So I would put a negative right here. This is called the standard notation, and this right here is the scientific notation. Okay, so multiply the new number by 10 raised to power n, and the n is the number of places you move the decimal point by. If you move the decimal point to the left, then n is positive. If you moved it to the right, n is negative. I do not like to remember left or right. An easy way is if the original number is 1 or larger, meaning it's a big number, your n is positive. Large number, it's a positive exponent. If your n is negative, that means it's a small number, meaning it is less than 1. That's it. Left and right, you don't have to memorize. Let's try this one. On top, for example, this, the first step is I need to locate my decimal. There's no decimal right here, which means this is my decimal. It's not given to me, so I'll put it at the very far end of the number. Where do I want it? I want it right after the first digit, non-zero. So I'll move it 1, 2, 3, 4, 5, 6 place values, which means my number is 2.5 times 10 raised to power 6. And because my original number was a very large number, that means my exponent is positive. If you don't see a sign, that means it's a positive number. So if it's just written as 2.5 times 10 raised to power 6, that's also okay. You don't need to put a plus sign. Let's try this. I'll put the decimal right here. I want it at this location, so I'm moving it 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, which means 1.37 times 10 raised to power positive 11, because it's a very large number to begin with. The last one, I want the decimal here, so I need to move it by how many places? 1, 2, 3, 4, which gives me 3.26 times 10 raised to power 4, but it's a negative 4 because my number is a small number to begin with. And that's it. This is your standard notation, and these are your scientific notation. Now let's see how you can go from scientific notation to standard notation. How can we do reverse? Let's try some more questions. For example, going from scientific to standard notation for these. This is the scientific. How can we do standard? It basically just the opposite. Okay. In order to go from scientific to standard, we reverse the process and move the decimal number units indicated by the exponent. If the exponent is positive, that means the number is large. If the exponent is negative, that means the number is small. Okay, so you add zeros accordingly. If the exponent is positive, the number is large, so we will add zeros on the right side, right? If you have 1,000 bucks, the zeros are on the right because it's a big number. If the exponent is negative, we add It's a small number, so we will add zeros on the left side. For example, if somebody has 0.000001 in their account, then they're broke, right? It's a very small number. Okay, so let's try this. For example, 1.528 times 10 raised to power 5. So I write 1.528. I need to move this decimal by 5 place values, and it's a large number, so I will add zeros on the right side. So 5 places, which means 1, 2, 3, 4, 5. So my decimal is basically should be here. So whatever empty spaces you have, you put zeros as your numbers there. So actual standard notation is 15280. Okay, for this 1.64, I need to move it by 7 places. I will be moving it to right because again it's a large number. Why? Because the exponent is positive. So 1, 2, 3, 4, 5, 6, 7 empty spaces, add zeros, which gives you 164, 1, 2, 3, 4, 5. Next, 1.35 times 10 raised to power -5, which means it's a small number. So zeros will be added, but to the left side. So 1, 2, 3, 4, 5. Every empty slot, I will put a 0, which means my decimal is here. So what is my number? It's a 0.00000135. 8.28 times 10 raised to power -3, which means I move the decimal by 3 places, but to the left side. Again, why? Because it's a small number. So 1, 2, 3. My decimal is here. So 1, 2 zeros, which means it is 0.00828. That is your standard notation. Let's try an example. This is the population right here, 301,786. Express this number in scientific notation. So no decimal, which means I'll put the decimal right here. And I want scientific, which means I want the decimal here. So I have to move it 1, 2, 3, 4, 5, 6, 7, 8 by 8 places. So my number is actually 3.01786 times 10 raised to power 8. And it's a positive number. Why? Because my number is large. The original number is large. So that's your answer. So here are some more questions for you to practice. The answers are given to you in the slide. So if you want to just stop the video, try it on your own and just check your answers, that's all good. But if you still need help, you can continue watching. Okay, for example, convert these into scientific notation. So scientific means I want my decimal right here between 1 and 2 after the first non-zero digit. So it is a large number. I have to move my decimal from here 1, 2. 2 place values, so it is going to be 1.234 times 10 raised to power something, which is 2. It is going to be positive 2. Why? Because it's a large number to begin with. Large number means positive exponent. Next is this number. So currently my decimal is on the right side because no decimal is given, so it's at the end of the number. I want my decimal to be present right after 1. So 1, 2, 3, 4, 5. So I'm moving it by 5 place values, which is 1.45 times 10 raised to power 5. And it's a positive 5 because it's a large number. This right here, I want my decimal here. I move it by 1 place value. So it is 2.525 times 10 raised to power. I moved it only 1 over. So it's a 1 and it's positive because it was a large number, 25. 1.45, I do not move the decimal at all. But because it is an scientific notation, I need the multiplier here. And my exponent in this case would be 0 because did I move it by any place values? No. So I moved it by 0 place value. So that's my exponent. Same thing here, 8.0012 times 10 raised to power 0. If it is a scientific notation, you need 10 raised to power something. You need the multiplier and the exponent there, even if it's a 0. Okay. Next is this. I want my decimal to be here, right after the first non-zero digit. So I move it by 1, 2, 3 place value. So that is 2.34 times 10 raised to power 3, and this would be negative 3. Why? Because it's a small number. It's less than 1. Small number means negative exponent. Next, I move it here. So 1, 2, 1.23 times 10 raised to power negative 2. This one too, I want the decimal to be right after 8. So we go 1, 2, 3, 4, 5, 6. 8.706 times 10 raised to power 6, but negative, right? 1, 2, 3, 4, 5, 6, correct. So 6 places, but a negative because it was a small number to begin with. There are some more examples here. It's asking you to write it in the standard form. Again, your choice. If you want help, you can continue watching. Otherwise, you can just try it on your own. 2.1 standard form. It's 10 raised to power 3. It's positive exponent, which means it's a large number. So I will add zeros on the right. So 1, 2, 3. Empty spaces, which means my number is 2100, 2100. Then this number 9.66, exponent is 4, so I move it by 4 places, but it's a negative 4, which means it's a small number. So I will add zeros on the left side. So we move by 4 place values on the left. 1, 2, 3, 4. That would be 0, 0, 0 right here, and decimal here, which means my number is actually 0.000966. You don't have to keep drawing this if you practice it enough, but for now, please draw these so that you know how many place values you're moving it by. 6.04, so negative 2, which means I move the decimal to the left. 1, 2, by only 2 place values, so a 0 here, decimal here, which means 0.0604. 4.02 times 10 raised to power 0, which means I don't move the decimal at all. So 4.02. 3.3, 10 raised to power 1. It's a positive exponent, which means it's a large number. So I move it towards the right. So I'll move it from here to here, just 1 place value, which means no zeros added. It's a number 33. 1.2, 10 raised to power 0. So do not move it, which means the answer is 1.2.